This is exercise 6.135, where we're asked to construct a confidence interval for a population mean, and we are given the population standard deviation, and therefore we can use the normal distribution, the Z. And so our formula for a confidence interval for a mean using the normal distribution is as follows. Our X bar is our sample average, and we can see that our sample average was $131. Our critical value we'll need to get from the table of critical values for the normal curve, which we'll do so in a moment. The sigma over root n is called our standard error of the mean, and so we take the standard deviation of the population, sigma, and we divide it by the square root of our sample size, which is 40 in this case. Now, one part of this question has us using 90% confidence. The other part of this question has us using 95% confidence. What we're going to see is the difference is just that critical value. If you want to be more confident, then you most certainly have to go more standard deviations out from the center of that distribution in order to be more confident. You'll get a wider interval. So for a 90% confidence interval, we are going to use 1.645 for our critical value. And for a 95% confidence interval, we'll use the 1.96. And we'll go about calculating the lower limit and upper limit of both intervals using the very same methods we've used in previous exercises, which I've made previous videos about. Now, as I said, the higher level of confidence will be a wider interval, and that is because the critical value is bigger. We need to go out only about 1.645 standard deviations in the normal curve to capture the middle 90%, but to capture a larger percentage, we have to go out a greater number of standard deviations. So that would be 1.96 standard deviations. So I'll start with the 90% confidence interval. In a 90% confidence interval, what we're doing is we're basically capturing, again, the middle 90% of this normal curve. Now, this table that we have access to in our textbook gives us the area between the center to the upper end of that interval. So it's going to be half of that 90%, or 45%. If I change 45% to a decimal by moving the decimal point 2 places to the left, that's 0.4500. I am looking for a z-score that corresponds to an area in this table of 0.4500. And I see that these two are equally as close to 0.4500. So what I'm going to do is find their z-scores. Their z-scores are 1.64 and 1.65. And I'm going to average them since they're equally as close. So I'm going to add them up and divide by 2, and I'll get a critical value of 1.645. So now I'm going to go back and I'm going to insert that for my critical value. But while I'm here, I might as well go ahead and grab the critical value for 95% confidence. 95%, using this table, we need half of it. That's 47.5%. So for 95%, we're looking for 0.4750, and we can hit it right on the nail right on the head. That corresponds to a z-score of 1.96.